Hi, in this video we're going to talk about transformations of functions and function operations, adding, subtracting, multiplying, dividing, and composition of functions. So let's start with the transformation of functions. So here I have a parent graph, f of x equals x squared, so it's our standard parabola with vertex at 0, 0. So what does it mean to create a transformation? Transformations allow us to sketch graphs related to the parent function in a quickly manner. So by identifying what the transformation is, we can look at a graph and then recreate it very quickly. In this case, I have this transformation, so notice that the vertex got moved up. So that lets me to believe that the transformation that happened here is a vertical shift. So I can say this is probably f of x plus a constant. So I can say f of x plus c. Now because it's my scale here, that's a 10, and that's 5 is probably in the middle, I'm going to say possibly f of x plus 2, maybe, right? But this allows me to say, oh, there was a vertical shift upwards of up 2 units. If it was f of x minus c, that means we would take the parent graph and we move it downwards by however many units of c. And so what other transformations are there? If there's a vertical shift, there's probably a horizontal shift. So what does a horizontal shift look like? So here is our function f of x equals x squared, but now notice that our parent graph, the vertex is at 0, 0. It's called a parent graph when it's just a standard power function. And once you've done a transformation, in this case a vertical shift, and in this case a horizontal shift, it's done on the parent function. So this one, we have a horizontal shift. And let's call this that the vertex got moved to, that looks to be right about the middle. So let's say that that's 5. So that means that this is f of x minus 5. So you recognize a horizontal shift when the inside is what's affected, right? So in this case, this is essentially x minus 5 squared. That is the function. So here, this is, if I'm calling that number 2, then this function is x squared plus 2. And so we recognize a vertical shift by the addition or subtraction of the constant happens outside of the x. Right here is x squared plus 2. The horizontal shift happens on the inside of the function. So x squared became quantity x minus 5 squared. So this lets me know that a horizontal shift is happening. Now, what about when both are happening? So this graph here is still our parent graph, right, or parabola, but now it has both. It has a vertical shift and a horizontal shift. So notice that now the vertex, so we're looking at the vertex, it moved. So what does this look like? So it looks like we do have a horizontal shift, so this will be f of x, and it moved to the left. So let's call that a -1 maybe. Right, I'm just kind of guesstimating based on my scale here. And sometimes you may have to do that if you can't tell what the values are. So that looks like a -1, so that means that this will be f of x plus 1. And then looks like there's a vertical shift downwards. So let's call that a -3. So it'll be f of x plus 1 minus 3. So why the plus 1 when it went left is because this is really, notice that when there was a horizontal shift here, we said x minus 5, and it moved to the right. So essentially you're trying to figure out, well, in the paragraph, the vertex is 0, right? Is when x is 0. So when it's on the inside, what makes this 0? What makes x minus 5 0? 5. What makes the inside -1? It will have to be x plus 1. So this function, then I can rewrite it with the square as x plus 1 squared minus 3. And I can identify the vertex from here because this is in vertex form. So it'll be -1 comma -3. And so that makes sense. So when you're looking at a parent graph, and you have a shift, you're trying to figure out where did the features of the parent graph go. So in this case, where did the vertex go? If you had something that had asymptotes, what happened to the asymptotes? So if you had an asymptote at 0, then +2 will make the asymptote move up. And so that's how we use those kind of transformations, horizontal shifts and vertical shifts, and then this one has both of them. What about other types of shifts? Let's try another example. So if I have this function, again, I have a quadratic f of x equals x squared minus 6x plus 5. So let's figure out what the graph of that function looks like. So here we have our parabola. We can see the vertex, and you can verify this graph, right, by doing the minus b over 2a. The vertex will be then minus a minus 6, that's then minus b, so 6 over 2a, a is 1, so 6 divided by 2 is 3. So that means that that vertex, the x value of the vertex is at x equals 3. And we can plug that in to find the y value. But this is what the graph of this function looks like. So we could do a vertical shift, a horizontal shift. This is already shifted from the parent parabola graph. Now, what other transformations could we do to such a function? So say I have this graph now. So if I told you that this graph on the right is a transformation from the graph on the left, the question is, what did we do? How did we go from this graph on the left and then do something with the transformation and get the graph on the right? So what happened? So think about that for a second. So what was it that we did to go from this on the left to that graph on the right? Can you spot it? So essentially this new function, we took the absolute value. So this is the absolute value of f of x. Right, what do you know about absolute value? Usually what we hear is that absolute value makes everything positive. And that is true, essentially because the absolute value of something, the definition of absolute value is that, so the absolute value of f of x is going to be f of x, right, for f of x greater than 0. So if it's already positive, it stays positive or equal to. If it's 0, it stays 0. And negative f of x when the values are negative. Right, and this essentially, I'm bringing this from our definition of absolute value. What is the definition of the absolute value of x? Is x for x greater than 0 or equal to, and negative x when x is less than 0. So think about examples of this. So if I ask you for the absolute value of 3, what do you say? 3, right? It's already positive, so it stays positive. So that's what this is saying. So if x is already positive, you just get x back. But what about the absolute value of -4? The absolute value of -4, you're used to saying, well, it makes it positive, it's 4, right? But what this essentially saying is that if it's negative, you give the opposite, the negative of it, right? So using this definition, the absolute value of -4 is negative 4, which of course is the same thing, but it's just telling you to give the opposite. So that's kind of what this is too. So looking at the graph, whatever is positive stays positive. So this part over here is already positive, right? The y values are positive. So that will stay positive. Right? F of x is just a fancy name for y. So you're looking at the y values. So this is the line y equals 0 is the x-axis. So above the x-axis, y is positive, and below the x-axis, y is negative. So that's where, so y is positive here. So the absolute value of a positive number stays positive, and then y is negative in this part, right? So this is where y is less than 0. So when we're less than 0, we're going to do the opposite. So it's negative, we want it to become positive, so that's why that little loop down here comes up here, because anything that's negative, we're making it positive. And so that is the absolute value of a function. And if you think about what the absolute value of x, right, think about what is the line y equals x look like. And that is just your standard line. So this is our graph of y equals x. And so based on the definition, we have for the absolute value, we will have that when x is positive, it's going to stay positive. So if you think about trying to graph the absolute value of x, how would we graph that? Well, this says when x is positive, keep it positive. So I'm going to have that line. And then when x is negative, right, when x is less than 0, when x is negative, we're going to graph the line y equals negative x. So essentially this part that is below the axis, it's going to come up. And that's what gives us the v. And there's our absolute value, right? So then whatever was below the axis over here, then the absolute value makes it positive. And so that's how we end up with the v for the absolute value. All right, so those are some of our transformations. There are other transformations out there, right? If I do the negative of the function, so negative f of x, it just will turn this upside down. If I look at the parent graph, y equals x squared, this is my parabola. If I do negative x squared, it will be this parabola turned upside down. So those are other types of transformations that you could have. You can multiply by a constant, right? If I have 2x squared, then it makes it narrower. If I do 1/3 x squared, it's going to make it wider. So those are types of other transformations that we can do. All right, so on the next video, I'm going to talk about operations with functions and composition of functions.